Okay, so let's start writing electronic configuration for aluminum. So for aluminum, we have found there are total 13 electrons, right? And when we fill up electrons, we can write 1s2, 2s2, 2p6. So out of 13, 10 are gone, 3 left. So we can write 3s2 and then we can write 3p1. So that's a longhand notation for aluminum. Now when we write shorthand notation, okay, so when you look at the periodic table, the noble gas before aluminum, which is neon, it has total 10 electrons. So that's, instead of writing the whole thing, we can write neon in a bracket. And then we can write 3s2, 3p1. So that will tell you shorthand notation. Shorthand notation. And this is longhand. We can write longhand configuration. And we can write shorthand configuration, electronic configuration. Okay, now let's work on carbon. Carbon has 6 electrons. When you write electronic configuration 1s2, 2s2, 2p2, total 6. How do we count? 2 plus 2 plus 2, total 6. Alright. Now when you write shorthand configuration, helium is the noble gas before carbon, which has electronic configuration 1s2. So instead of writing 1s2, we can write helium in a bracket, and then we can write 2s2, 2p2. So that's going to be a shorthand configuration for carbon. Okay, now let's work on iodine. Iodine has how many electrons? 53. Now we can write 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, and 5f, and then we'll put the arrow, and then we'll fill it out, electrons. Let me read. Okay, and then we'll fill it in. So that will help you writing electronic configuration. So when you write electronic configuration for iodine, we can say 1s2, 2s2, 2p6. Out of 53, 10 are gone, 43 left. Then 3s2, 3p6, 4s2, another 10 left, 33 left. Okay, and then we have 3d10, so another 10 left. So we have 23 left. 4p6, 5s2, alright, and then 4d10. So then we have how many left? 5 left, so 5p5. So when you add them all electrons, you get this electronic configuration. Okay. Now, when you look at noble gas before iodine, which is going to be krypton. So we can write krypton, which has electrons 36. So that's 10, 10. So that's the electronic configuration for krypton. Instead of writing the whole thing, we can write krypton. And then we can write 5s2, 4d10, 5p5. That's shorthand notation for iodine. Now we are going to work on for sulfur. Okay. Now sulfur, when you look at periodic table, let's go to next slide. Sulfur, which has 16 electrons. When you write 1s2, 2s2, 2p6, then 3s2, 3p4. That's the electronic configuration. That's a longhand configuration. And then when you write shorthand, this is the configuration for neon, so we can write into bracket neon, and then 3s2, 3p4, that's a shorthand.
So could we use
configuration. Now let's work on copper, couple of more, and then I will come to your question. Just a minute. Copper, we have 29 electrons. Okay, so when you write electronic configuration, 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, is that right? Let's see, 6 is 10, so 3d9, right? And when you write shorthand notation, this is electronic configuration for argon. Argon has how many? 18 electrons. So that's electronic configuration for argon. And then you can write 4s2, 3d9. In most of the books, it's like argon, 4s1, 3d10. That's how it's mentioned. But we'll go over that. Now let's quickly work on calcium. Calcium has 20 electrons. And when you write electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, and it is 4s2. That's the longhand notation. And when you write shorthand, this one, instead of writing the whole thing, we can write argon, which has 18 electrons, and then 4s2. So that's shorthand. Shorthand notation for calcium. So that way you can write longhand notation and shorthand notation for